Hello, welcome to yet another video on Engineering Economics 2373. This video is going to be about single cash flows computations. So continuing with our discussion, remember we can represent using diagrams a series of cash flows. In the simplest of the cases, we would have just one cash flow and then several periods, and we are getting the cash flow back. In general, we're not going to be using scale figures. These are just a representation when these cash flows are happening. And in this representation, we have let's see, 1, 2, 3, 4, 5, 6 periods, and after 6 periods, we will receive our money back if we decide to make an investment. Remember, this cash flow going down represents money that is no longer available to us, and this could represent an investment. We make the investment, we cannot spend the cash, we can wait 6 periods, and then we will get the money back available to us, and that is why the arrow is pointing up. And since we have a cash flow that is coming in the future, the amount that we will receive here is going to be affected by an interest rate. Let's consider an interest rate, say 8%, and the question could be, well, if we now knew that we need $1,000 6 periods from today, the question is, how much do we need to invest today if we want to have that amount? So in this occasion, what we need to do is we need to compute the present value, and the present value depends on the fact that we know that we will want $1,000 in the future, and now we need to compute a present value. Given that we know the future, we know that the interest rate is 8%, and we know the number of periods to be 6. So in other words, this present value is going to be $1,000 times, now the interest rate is 8%, so the factor would be 1 plus 0.08, and the power now is a negative power. We have to the negative 6. So that would be the amount, and we can make this computation in the calculator. So we have 1.08 raised to the negative 6. That number becomes $1,000 times 0.630169. Now this is P given F for 8% and n equals 6. Of course, when we multiply that number times $1,000, which is the initial investment, or the final value, that we will need, that translates in us needing to invest $630.17. If we invest $630.17, we will have at the end of 6 periods $1,000 available for us. Sometimes we have more than just one cash flow that we will need to consider. Imagine, for instance, the series of cash flows that we have in this diagram. Some of these cash flows are being available to us in periods 1, 3, 5, 6, and 9, and those are the cash flows that we will receive in those periods. At the same time, we have a negative cash flow at t equals 4 that could represent an investment or an expenditure that we will have to make at t equals 4, and therefore that money will not be any longer available for us. These computations obey the same behavior as we have done with single cash flows, and we can compute these series of multiple cash flows at different times with different amounts if we compute them one by one. So let's make an example. So when we have multiple cash flows, we can make a diagram equivalent to what we had before. And let's say now that we have the passage of time, these are equivalent periods, and let's say that we have time t equals 0 here, and then period 1, 2, 3, 4, 5, and 6. This is a 5. Okay, so let's say that we have a cash flow that we want to receive at t equals 2, and maybe another cash flow that we want to receive at t equals 5, and yet another cash flow that we want to receive at t equals 6. Let's consider that the cash flow excuse me, at t equals 2 is $1,000. The cash flow at t equals 5 is 1,500, and the cash flow that we want to receive at t equals 6 is let's say 1,700. So if that's the case, we could be interested in knowing, well, if we want that amount of money to receive that amount of money in the future, how much do we need to have today? How much do we need to have today? And that would be a present value, and we have the other cash flows occurring in different moments in time, so we can compute that as the summation of all these cash flows. So we have the present value should be equal to the first cash flow, the cash flow that happens at t equals 2, the cash flow that happens at t equals 2, which is 1,000, brought to the present, that is times p given f. We have not specified an interest rate. Let's say that the interest rate is something different. Let's use 5%. So the present value is p given f for 5%, and then this is happening at t equals 2, and that would take into consideration the first $1,000. Now on top of that, we want to receive also $1,500 at t equals 5. So we have the present value equivalent is 1,500 times p given f, also for 5% and 5 periods, plus 1,700 times p given f for 5%, and let me write that here, 6 periods. So we can compute those numbers. So once we have the equation, we can use the formula that relates these factors, p given f, and we can compute these factors for each one of these parameters, changing basically just the period. And when we do all the arithmetic associated to these computations, the final result is 3,350 with 88 cents. That is the total amount that we need to invest today in order to withdraw $1,000 at t equals 2, 1,500 at t equals 5, and 1,700 at t equals 6.